Thank you to all the organizers and associates for this invitation. Quickly, Shakti Sustainable Energy Foundation, we work in in an ecosystem engaging all sorts of stakeholders towards our effort to decarbonize the energy, power and energy, that sector. And my specific focus there is with Electric Mobility Initiative, which is a multi-funder platform housed at Shakti. And goal for us is to focus in the transport sector 100% decarbonization by 2050 or before. That's a small introduction what we do. Now, I don't have a presentation. I wanted to really touch upon various points, areas of interest for think tank, policymakers, industries. Also, one of the largest stakeholders is the end consumer. We all sitting in the room and people who are listening possibly remotely, if at all. So let me just quickly touch upon the topic is energy storage with future of electric mobility. It's very well coined. Both are very strongly linked, which a previous speaker has emphasized on. And historically, let's see what is that energy. I mean, we have sorts of known energy. Universally, we have primary source of energy is nuclear power, which is nothing but sun. And I guess possibly nature was knowing it, so keeping it millions of miles away and making sure we only reap the fruit out of that energy. Now, considering the fossil fuel and the renewable sources or the electrical energy, the fundamental difference we have seen, especially when it comes to electric energy and its applications to mobility sector. I'm trying to touch upon a bit technical here. We know ICE engine works on principle of thermodynamics primarily. And what we see here in the electric mobility, it's the electric powertrain. For all known physics or engineering, people know that the efficiencies which are best of best achievable in electric machines is of the order of 90%, considering all sorts of losses. And ideal thermodynamics Carnot cycle, all that is not even 26%. Ideal, they say 49%, which is like absolute 0 to the 100 degree, if you have to cycle that. So knowing that, in practical terms, the best of best achieve is close to 25 to 26%. That to a stationary plants, which are captive power generating plants. And we know that that's not the case with the mobility, right? We can't have all sorts of advantage which a captive plant delivers, where you can extract all the residual energy content before you really discharge. That's one aspect you're taking. However, I think in this room we all are aware, calorific value of fossil fuel is still one of the highest, right? Even whatever best we know in electrochemistries, the type of storage element, be it lithium and many other chemistries, what we see that gasoline accounts for close to 4 to 5 times higher energy density. That means for a given volume, the energy what can be put in a fossil fuel is amazing. On the flip side, ability to convert it efficiently in the useful work is less than, say, 1/5 or lower than that, with hardly anything left out as it's hitting to the asymptote in terms of researches in that, unless there is something really miraculous happen. Now, when we look at the electric storage, just bringing the analogy, we see well to grid and grid to the dispensing station and dispensing station to vehicle. When it goes to vehicle, it becomes tank to wheel. So let's consider A, B, C, 3 legs and bring a comparison with the ICE vehicle to the electric vehicle. What we see, tank to wheel, which is where the useful work is happening within the dense populated city limits, be it CBD Central Business District or those areas, we are most concerned that lowest emissions should happen because there are density of vehicle is too high there, right? So technically, if you just compare one element, which is the C element, where it is tank to wheel, we are able to clock in electric vehicle not only the best performance to the calorific value, which is staying inside tank, also no heat. I don't know, I mean, how many of us have seen thermal imager camera or images of that sort. If you just put up through a drone imager camera, each vehicle is few kilowatt of heater on the road, and we have a queued lines of vehicles, hundreds of them. They're like heating element. Way back when I was a kid, we have seen heaters with the filament, right? It is exactly the same. So beyond the one issue which we all are talking about, efficiency of transferring the energy from its nature to the mobility, the second biggest problem comes in as a heat. And how we counterbalance it? Burn again a set of fossil fuel, generate electricity, and bring the air conditioning to take care of, or we all know the type of crisis we are seeing in. So it becomes an oven we are all living into, especially the denser populous areas with high-rise building. It's like a woolen jacket or sweater, right? These are, if you just go up and see, it's all obstructing the free flow of air, and therefore the heat stays localized there. Now, third is the emissions. Anyway, we talked about, emissions first, second is heat. Third is the noise. Compare that with the EV. There's nothing people rather have talked about the last couple of years to bring some sort of noise to make sure it does not become a safety threat. So there have been regulatory things. When I started working in EV way back 2009-10 with REWA, in Japan and all, we were just bringing those kind of a logical horn which can make people at least see that, yes, there's something coming. Yeah. So these are the couple of quick catch-up. Now taking this discussion further to storage. Now in vehicle, we see that as we are seeing the growth of vehicle and also the source of renewable energy joining to main course, any of these today electrical sources of energy, they can generate or be contributive as long as there is an immediate consumption, right? We can't pump in an electron to a grid where electron is not taken off from the grid by any load, right? So technically, this is one of the biggest challenge, and therefore offers a great opportunity for storage overall. So technically, we all are going to be seeing storage forever. Even if there are other sources of energies, we are talking about hydrogen, be it green hydrogen and all that, or even any other source of energy, as long as it passes through electrical system, it has to go and reside in a storage element. Now, storage doesn't mean only lithium or a couple of electrochemistries our last speaker was covering. We have huge many ways and means to find what is the right cost to our country, technology-wise, what is that right way of storing that energy. There have been ways and means like ultracapacitors, supercapacitors, one end various lithium and other electrochemistries. The third is kinetic energy systems, right? It can be a very high rotational energy, which is a standard physics or mechanics, which we use it for recovering that energy. Third is thermal, geothermal, then you convert it to a hydro system, which has been used in Europe for a decade back. So there are very many ways and means of having storage. Now coming back, bringing focus to electric mobility. Why I spoke all this, the element when we see as generations, we have options of various storage. On the one of the typical load we consider very well said is, and one of the largest load in future going to be mobility, electric vehicle. Now electric vehicle, we are seeing back in US, like Tesla when they started Powerall, way back here in India we started the same way. Knowing that in critical applications like automotive, when we use the storage element, which is batteries, we take them to their top of the life, which is typically top of 20%. What we stop it from the main course of services when they're hardly 80% or so, they're still so good for many other applications. I don't know how many of us have seen using our mobile battery pack. 50 to plus percent or 70 to 80% of them are refurbished, reused batteries. They're 18650 coming out of laptop and put it in those pack, which we historically have been using it without knowing it. right? So same way from here in electric vehicle, when we have a set of batteries which are coming out, they can be of very many use. One of the primary use where you generate further much higher revenue out of the second line of business, which I think earlier speaker very well said, second life of use of battery, right? Repurposing the battery. So when there are like large batteries, say large here, I mean to say high voltage batteries, high energy content batteries, like few hundred kilowatt hour, which is for a larger vehicle up to the truck, maybe 300, 400 kilowatt hour. And voltage buses maybe like 600, 700 volts or more DC. So there is going to be a, in the ecosystem, we need to create a arrangement where these batteries are traceable, they are taken back with the common buy-in from the OEM and other arrangements to break into the safety extra low voltage level, which is a typically less than 60 volt level, which is all we see in telecom and many other applications at home, the DC less than 60 volt. So bring those to that level so that they become very useful for at least small home backup. We all know in our common life here, especially in NCR and Delhi, I mean in Northern Belt, home inverter, right? 20 years back or so, or little over, when home inverters kicked in, we all know that time there was like, kerosene generator, all that what people have been using at home. Very quickly, they left all that, they all switched over to home inverter, right? And exactly similar is what we are very clearly going to be seeing in the electric vehicle space when these vehicles are now going to be, floating all around the places, not only the key cities, but to the remote, rural areas. The biggest advantage for electric vehicle is there's nothing like adulterated electron. Have anybody heard about it? Or adulterated electricity? No. So the source of energy, when we consider this as a electrical energy, it is the purest form and easiest way to any remote site as soon as, or as long as they get some or the other way of sun or wind, they can directly tap that energy and put it to their vehicle. And we know that most of those locations, the type of vehicles are used. India is an economy of smaller vehicle, right? So we have been seeing this is going to be a very big plus to add to the economy, overall society, upliftment, ways and means of increasing the earnings, so many other factors. So this is a one very strong case along with the DC microgrid and all those taking the leverage and advantage of that. And while these are always very well connected to the main grid somewhere or other. Many places where bringing the grid because of the size of society, of the village or town, the rural area, may not be viable at all because of ABCD reasons, because of geographical way of pulling the wire all the way there, et cetera, et cetera. These are the very good model where you can have a direct source of energy which is renewable, captured, stored in a very cost-competitive way, which is energy storage element, be it of various categories and types depending on the needs, and use it for your mobility beyond charging your mobile, beyond making your fan to run, and beyond making our all other lights and other key gadgets, critical loads to first function. After that, this is the very big instrument for thrust to the economy, especially to the type of people, the society, and especially our elderly, kids, and women, right? In all these parts of society or remote locations, they find this as a very good means as a backed up store energy so as they can very well use it. And this is going to be of much higher quality than making a small lantern, which has been historically a great success, but there have been really bitter experiences of not getting a good quality. But having this coming from auto grade, to certain level, qualities are good. We have had some bitter experience again there. It's early days, but what we are seeing, auto and healthcare, avionics, all these are high liability businesses. You can't think of expecting anything below one of the finest quality and reliability, right? So technically, if we are seeing now vehicles announcing for 5-year, 8 years type of a 100% replacement warranty, which is what end user doesn't bother whether he is going to be buying a petrol car or a battery car. They don't want to really get into that mode of responsibility for battery. That has to mature our storage has to mature to that level of quality. Once that is built to that quality, that pack or module in between are going to be of the similar capability, and our circular economy, the policy and other initiatives, the discussions we are having, are trying to see how best they can be made traceable, so as we know, starting from the source of battery to the module, finally when it gets into the secondary use, by either breaking it to smaller aggregates, it is all traceable up to the level of last leg, where the APRs can be very clearly made to the advantage of the people who are using towards the last leg, and that goes back to the recycling process or recycling system. So these are the advantages or overall ecosystem what in electric mobility space, which we are observing. Having talked about this, a few things which are on our priority. We are looking at heavy-duty commercial vehicle to be coming faster in this space, as 1/3 of all the emissions in transport sector are attributed because of our commercial vehicles which are on the road, right? And that has been historically increasing way, way faster as our urbanization and many other overall earnings are improving, et cetera, et cetera. So this material and our country itself, as the industrialization, everything is adding more load on the freight and commercial vehicle. So that's a very, very priority element to look at it, and therefore we'll be needing much more big size packs, and therefore R&D, skilling, technology, everything at home. So thanks for that PLI initiative. We know that a couple of our businesses are putting really large bets on it, right? So anybody who is in energy sector is one thing, but apart from them, the other players who are never in this space are jumping in is a very good sign and shows the type of promise. So that's one thing. Second is priority is what we are looking at, how good we really make different states and other clusters to be zero emission zones, right? And try to see those kind of initiatives help create a room for faster adoption of electrification, and also ensuring enough of the material which is down the line coming out from the vehicle use is going to be of recycling, goes back to the recycling process rather than we just put up the load on the mining. So these are the couple of thoughts I just wanted to share. I'll be here for the other questions, if any. Thank you very much once again.